everyone. Today I'll be doing some examples for binary multiplication and division just to show you how it's done. Okay, so we'll be doing binary multiplication and division. So before I start, I just want to let you know that a binary multiplication and division is mm, exactly the same as you do it with normal numbers. So, but let's just start with a simple example. Let's start with multiplication. Okay, so let's say, for example, you have 235 times maybe 65. Right, and we remember to multiply, we use the long multiplication method, which is 5 times 5, which is 25. So you have 5 there, then you send 2 on the top. Then again you say 5 times 3, 15, plus 2, 17, you send 1 there. Then that will be 11. Then if you remember, you skip this one place. Then you do the same 6 times 5. 30, then it's going to be 3 there, then 6 times 3, 18 plus 3, which is what? 121, yeah. And then 6 times 2, which is 12 plus 2, 14. And then we add this together, right? So 5, 7, 2, 5, 1. When we get our answer. So similarly, this is what we do in binary as well. So let's say, for example, we have 101 times 1, 1. And if you remember in binary, 5 in binary is 101. Then 3 in binary is 112 with the base 2, right? So it's 3 times 5. And we know in reality 3 times 5 is 15. So you should get 15 here. So let's do that. So yeah, we do the same as the long multiplication, which is 1 times 1 gives us 1, 1 times 0 gives us 0, 1 times 1 gives us 1. Then we skip the place. Then we go to the second one here, this one. Then 1 times 1 is 1. 1 times 0 is 0. Then 1 times 1 is 1. Then you add everything together. So that will give you 1, 1, 1, 1. Right, so this is a simple example for us to do multiplication in binary. And if you check the binary conversion, that 1, 1, 1, 1 is 15 in binary. Right, so let's do another example. So it's easier for us to understand. Let's say now if you have maybe a number like maybe just a simple example again, 101 times 101, right? So if you check, this is, I believe, 13, and now this is 5. So 13 times 5, right? Let's try to solve this. So it's going to be 1 times 1, then 1 times 0, then 1 times 1 again, then 1 times 1, right? Then we remember we skip a place, then let's just change the color. Then we go to this 0 here. So it's going to be 0 times 1, which is 0. 0 times 0 is 0. 0 times 1 is again 0, and 0 times 1 is 0, right? And then we follow the same for this one here. So 1, and this time we skip 2 places, right? If you remember the basic rule of long multiplication, so we again do 1 times 1 is 1, 1 times 0 is 0, 1 times 1 1, and then 1 again. And then we perform addition for all of this. And if we add, we'll have 1 plus nothing, that will be 1. And then if we move down this line, which is 0 plus 0 is 0, then here we have 1 plus 0 plus 1, which is going to be, if you remember from addition, 0 carry 1. Then here we'll have 1 plus 1 plus 0 plus 0, and that will again give us 0 carry 1. Just remember 1 plus 1 is what? 2. And then we put the 0 and we carry this 1. Then here we have 1 plus 0 plus 1, which is again going to be 0 carry 1, and that will give us 1 0. So this should be our final answer. And if we check that with 13 times 5, that should give us what? 65. So this should be 65 in binary, right? So that's with the whole number. Let's say if you want to do something with, let's say with a number with a fraction, for example. Let's take example from the exercise. Let's say this one B. If I can copy, let's see, and paste it here. Yeah, there we go. Right, so that is our binary value. Yeah. So we want to perform multiplication for this, which is 1, 1, 0, 1, 0, comma 0, 1 times. We just say 1, 0, comma 1, 0, 1. So this is our multiplication, right? So here I will show you a trick how it works. So the first thing we do is we just multiply it as it is. So we just start with 0 times 1, which is 0, then 0 times 0 is 0. Then we go to 0 times 0 is 0, 0 times 1 is 0, 0 times 0 is 0. Then 0 times 1 is 0, 0, right? Then you skip a place, then you do the same. Times 1 is 1, 0, 0, 1, 0, 1, 1. Now you skip 2 places. Now we go to this one here. Then we do the same. That is going to be 1, 0, 0, 1, 0, 1, 1. Right? Let me just move this. The middle, yeah. Then again, we skip what? 3 places, then we start with this 0 here. So it's just going to be 0, 0, 0, 0, 0, and 0. Then we come to this last one, and we'll be having 4 places. Now that will be 1, 0, 0, 1, 0, 1, 1. And then we perform addition for all of this. And we know that's going to be 0. 0 plus 1 is 1. And maybe then if we add this one here, this row that is going to be 1, then we add, let's say, then we add this row which is going to be 0, then we add this row which is going to be 0 plus 1 plus 0 plus 0 plus 1, which is 2. So we have 0 carry 1. And then we add this row here, which is going to be, we have only 1 plus 0 plus 0 plus 1 plus 0 plus 0. That is 0 carry 1. Then we add this row here, which is 1 plus 0 plus 1 plus 0 plus 0 plus 0, which is again 0 carry 1. Then we add this one here, which is going to be 1 plus 1 plus 1 plus 0 plus 1, which is, if you say, that is going to be 1 plus 1 plus 1 plus 1 plus 1 equals 1 0 0, right? Which is 4 in binary. So we put 0 there and we carry 1 0 there. And then we add this right here. So it's going to be 1 0 plus 1, which is going to be, just remember, 1 0 plus 1 is 1 1. So we have 1 carry 1, right? And then if we add 1 plus 0 plus 1, which is going to be 0 carry 1, and we add this 2, it's going to be 1 0, right? Now the question comes, where do we put the comma, or where do we put the comma here, right, in this? So the easiest way I do it to put the comma is what you can do is, I count these two values here for both of them. So here I see after the comma, after the comma we have one value and then another. So this one has two values after the comma, right? Then I check even here, this one as well has two values, right, after the comma. So I add 2 plus 2 equals 4, right? That means I will have, for my answer, I will have 4 values after the comma, right? So I just count 4 values. So I count 1, 2, 3, 4. So then that means I put my comma here. So that's the easiest way to comma. And if you forget about the comma, right, when you're doing long multiplication, so that means your answer will be 1 0 0 1 0 0 0 0 comma 0 1 1 0. So that will be your answer. So let's say if I go back to the example, and if I say, let's look at this number 4. I'll leave number 4 for you to solve, but how many values do you think will be there after the comma for number 4? So let's look at that. So to check, we have the first has 2 values, the second one has 3 values after the comma, right? So we'll have 2 and 3. So In this case, so in the answer we will have about 5 values. You can say after the comma. After the comma. And that makes it easier. So you do your multiplication, then you just check how many values after the comma for both of the values you're multiplying, then you add them together, and then you just say, okay, I'll have 5 values after the comma. So then from there you can calculate your answer, right? So that was multiplication, right? And let's move on to division. So binary division, again, it's same as normal division. So for example, normal long division. So for example, let's say you have 2, 5, 6, and I want to divide that by maybe 7. Right, so in this case we do our long division. So we just check how many times is this, where is 27 maybe going into 25, or what value can we subtract, right? And if you remember, I think so it's 3 times 7, that is going to give you 21. Then we have 0, and that is 46. Right, then we remember 7 times 6 is 42. So we can do that. 0, and we are left with 4 here, right? So in this case, we have a remainder 4. Or you can go on, but then you put a comma there, right? Because there is a 0 there with the comma. So when you reach the comma, if you remember from long division, you bring down that, right? Then that will be 40, which is going to be 5, and then you get what, 35. That is going to be 0 and 5. And then you do it so on, right? So it can go so on. So I'm just giving you a nice idea how long division look works, right? So let's start with a simple division, then we'll move on. So let's say I want to divide 15 divided by 3, right? And we know this answer is 5. But let's do that in binary. We know 15 in binary is 111 divided by 1, right? And then we need to know the answer. So let's do the long division method. So 1, 1, 1, 1, 1, 1. Right. So here I do a simple method for me that works. I check the first value first. So I check this value. So that is 1. So I check, is this value greater than or less than this value here? So is this, and if you check, is this greater than or less than 1, 1? It's less than, right? If it's less than, I put a 0 there, right? Then I move on to the second value, or I move on to the value with this together. So I check the both values again. Is this greater or equal to or less than? And we can say it's greater or equal to. If it's greater or equal to, I put 1 there, then I bring this here. So it's going to be 1 times 1, 1, and that will be and we minus in this case. So that will be 0, 0, right? And then we bring this one down. Correct? Yeah. Now what we do is, once we bring this step, this value down, now again we check this value here. Is this greater than or less than 1, 1? It's less than, right? So we put a 0 there. Then when we put a 0, so that will be 0 times 0. That is 0. So if we minus that, that will be 1. And we bring that 1 down. Right. And once we bring this one down, now we check. Is this value greater or less than? We say it's greater or equal to 1. So we just say, okay, it's 1. So we can put 1 there, and we say 1 times 1, 1. It's going to be 1, 1 minus that, then that is 0. So our answer is going to be 0, 1, 0, 1, 2, and which is 5 in binary. Right. Now let's look at another example. Maybe one from the tutorial questions. Let's do number 5 for binary division. So number 5 it was 1, 1, 0, 1, 1, comma, 1, 0 divided by 1, 0, 1 in binary, right? And then if we check 1, 1, 0, that in binary, well, you can do that, but that in binary should be 27, comma 5 and 101. Sorry, not in binary, in decimal. That's decimal. 101 in decimal should be 5. So here we are doing division for uh, for uh, 27, comma 5 divided by 5, right? And let's just solve this first, then we go to the binary one, because we will follow the same method or the rule. So just remember, when we do such division, we first check the first value. This value, is it greater than or less than 5? It's less than 5, right? So we put a 0 there, then we take the other two values, which is 27, which is now greater than 5 in this case, right? And then we can calculate how many times 5 goes into 27. And if you check, I think so it goes into 5 times. So 5 times 5, we get what? 25 minus that will be 0, 2.5, right? And remember, when we bring a point down, we also put a point there, right? Then we bring this 5 down, and that becomes 2.5. Or in this case, we just don't need that point here. So it's just 25, right? So whenever we bring something after the point, we also have to put a point there. So that will be 25, and we know that is times 5. And here we have solved this, right? Now let's do this in binary and see how it goes. Maybe down here. Yeah. So this will be 101 divided by 11011, comma 10, right? And then we do the same again. You check the first value. Is this bigger than or less than? 1 is less than 101, right? So you put a 0 there. Then you go to the other two values. Then it's going to be 1, 1. That is as well less than 101. Then we move on to the three values. That is 101, 110, and that is bigger than 101, right? So we can put, forgot to put the 0 for this. So here we can put 1 and then put 101 there, right? And here we just do subtraction. So 0 minus 1 cannot be done. So we borrow from here and that becomes 10, right? And 10 minus 1 is 1. We have 0 and 1 minus 1 is 1. No, 0, sorry. Right. Then we bring this one down here. And then we check again this one. Is it bigger than or less than? We said it's less than 101, right? So you put a 0 there. Then we bring down the other one. Now we check, is this bigger than or less than? We said it's, if you check, it's bigger than 1 is bigger than 101, right? Then we can put 1 there and then put 101 minus. And if we do that, that will be 0, 1, 0, right? And then if we, and if you remember, if we bring something down from after the comma, we have to put a comma there, right? Because now we are moving to this one here. So we bring this one down now, right? Now we check again, it's 101. So it's bigger or equal to, or we said it's equal to 1, right? So if it's equal, it's still going to be 1. Then we just say 101 minus, and we get 0. So therefore our answer for this one is in binary will be 101 and comma 1. And if you check, that will be also 5.5 in decimal. So as you can see, binary division and multiplication is exactly the same rules we follow with a normal numbering system, but in this case it's just 0 and 1, right? And just remember, to make your multiplication, binary division better, you have to practice the questions. Yeah, cool. Thank you.